Hi everybody, it's your buddy Brad here, and today I am going to look at alternatives to using elliptic and the bipolar variations. Um, Elliptic splits and bipolar splits and deviations of those are probably the most popular technique in using flame fractals. So there are thousands of um, examples out there, but in JWildfire and other programs, there are also other variations that you can use instead of elliptic and bipolar. Um, Today, someone said they couldn't figure out any other variations they could use in replace of using elliptic, so this is why I'm doing the video. So let's go ahead and get started here. I'm going to start from going to new from scratch. And just let's start with elliptic. Elliptic 2, it doesn't matter, they are pretty much the same thing with that, with the variations. And I'm going to just set a gradient of white here. Move myself out of the way. And now the easiest way to visualize, at least for this tutorial, is if you go on another variation, and we're going to select post log tile 2, set that to 1, then we're going to set it as pre. And this actually gives a pretty good representation of how the variation works. Actually, I am going to scroll down. I'm going to set 0.5 here, 0.5 here. Oh, and we need to set these spreads to 1. There we go. There we go. That's what I was looking for. So now, if you notice, if we scroll down on the mouse anymore, we start to get little areas here, which can actually be a good way of adding stuff in there if we want to. But for right now, we're going to keep it all at 0.5, so it's seamless. And then I will add links to what you can do to help fill in these. I'm going to add 2 links to tutorials by Rick Sidwell, and in those links, it gives more detail on the math and how to use the variations. I'm just going to show you the basic shapes of the variations. So, and then here you would actually have splits on each side of here. And so then I'm going to hit screenshot on this. I'm going to then choose bipolar. And then one of the big differences is between elliptic and bipolar is, if you notice, elliptic is kind of going up and down, Bipolar is going left to right. So here you would have the splits on the y instead of over with the elliptic, it'd be on the x. And then with bipolar, you know, we can shift. You actually just shift between one, anywhere between -1 and 1. Everything else is you can pretty much get because it just keeps on repeating and repeating. So it's between -1 and 1. And of course the default is 0. I'm going to rotate this back just so you can see. And now you can see how lowering the triangle adds the spaces here. And then I'm going to screenshot that. I'm going to start at the very top of the list. So to begin off with, we can use the acosec h. And wherever you see that the hard lines here, so you can tell this would be based on the elliptic shape because the hard lines are on the left and the right, like it is with elliptic. Then if we rotate, now you can see the hard lines a little bit better here. And then of course there's many ways that you can fill in these spots, but that is for other tutorials that have already been made. And then if we go to acosH, now here you can see the hard lines on the top and the bottom. So you can use that in place of bipolar. And of course we can also always set post, transform, and rotate. Also, another trick is if we hit pre-post define, hit yaw, and hit 90, wait a minute, hit 90 to also rotate it. So that's regular, then rotated 90 degrees. So I made sure I put 1 with the pre-post define. And in some ways this is actually better because it actually rotates instead of when you hit post, it may affect the fractal in some ways. So then, next is acosH. And we see that the hard lines on the left and on the right. And so that is more like the elliptic. Then all I have to do is skip a few here. Then we're going to select the arcsec H. I just realized I don't have my zoom on. One moment. That actually might help out. So I selected arcsec H. And so we've already gone through the ACOS H, ACOS H, and a COT H. Let me move this out of the way some here. Oh, I have push on. Oops, my bad. Okay, and then we can just rotate that just to see how it looks. So you see this is based on you can replace this with bipolar. So this can be replaced with bipolar. And then we're going to click on the arc sin H. Again, it's the same shape as bipolar. And that is arc sin H. And then we have arc tan H. So again, you can see we could use this in place of bipolar, or elliptic if we rotate it. Now, next one is a little tricky because it's is ATAN. You can actually, it's kind of fits because you can still use it with splits up and down. So that's mode 1. I'm sorry, that first was mode 0. This is mode 1, so it's going in the shape of elliptic. Then mode 2 is actually a square. And then that's all the modes. Next one is ATAN 2 spirals. Now this one was kind of the brainchild of Whitaker Courtney that he came up with. When it's used, it makes some really cool spiral effects. Give it a try. With this, it actually works better if you use tiles, like tile log instead of splits. I believe. Don't quote me on that. And then next, is XP2, I'm sorry, XP multi, right here. This was another creation by Whitaker Courtney. And you see if we, by default, it's set to ACOS 1. And so that gives us the bipolar shape. Then ACOS set to 1, bipolar shape. I believe all three of these give bipolar shape. But even though they're the same shape, the patterns that they make are totally different. It's just that they can fit in the same shape as those variations. I don't know if those type of variations actually have a name. I asked around, nobody really knew if they had like a particular name. You know, like flux is half plane. If you know, please let me know. And then next, we have Jack ASN. Now the Jack stands for Jacobi. There's actually quite a few types here. I'm going to start with 0. Now be warned, this variation is very slow and it's kind of a beast to use, but it does make some very cool shapes. And I believe they are all going from left to right, so up and down. So this is type 0. Now this one's kind of tricky because we actually have the hard shapes here on the top and the bottom and on the sides. Whoop. Now here you see I'm having to actually reduce my mouse more to actually get more of the detail going. Take 2. Now we have too much space, so let's increase it some. Again, this has the hard edges on the tops and the sides. Now this is kind of a weird shape because it has kind of a curve here and a curve down here. So it's this is where they get a little interesting. And here's another one. You can see how it kind of cuts here and cuts out here. But you can still tile them in a way, probably with more, I use more with tile law. We have type 6. I believe that is it. Yes. Let me check my list here. Next we have Jack Elk. Another, again, this one kind of goes up and down and left to right. So you have the hard edges here and here. So these kind of fit, but not really, but you can still use them tiled. The next are the square root ones. So back to 0.5 value on the X and the Y. Now these are kind of the same as the ones that we've already covered up here, but they have a square root added to them. So it drastically changes the shapes of them. So we have square root with a cosec h. Sorry. And we see the hard lines are on the top and the bottom. Top, bottom. Then square root. You can probably fill the centers here with a nice blur or bubble or hemisphere. And then square root a cos. Square root a sec. Square root a sec h, sorry. Square root a sine h. And square root a tan h. So now that we have all those, what's really cool is if we select linear, and then select pre-recip, we need to set that to 1. First of all, I'm going to set up and come back up here. Maybe not. I think a sine h is similar to bipolar. So we have pre-recip. So if we don't have the reciprocal power set, it is the same as using, I guess we don't have an a sine h. We have so we have a cos h here. Yes. Yes, they aren't quite the same. I guess they are different. Yeah, I have. Okay, so that's a cos H power. Those are the same. So when using pre-reset, you need to have the reciprocal power or the divide power active, or else you might as well use the regular. They also have to give you some other options. That's what makes this this and post trig two very powerful variations, because you can use those all the variations we covered so far in one variation. So I'm just going to go through these real quick with the reciprocal activated. And then we can also activate the square power as well. I'm going to disable that. So we have a tan H, a sec H, a cos sec H, a cos and what's cool is we can also move it and scale it in different ways. So it acts like the scale with bipolar. And then next we have post trig. And we can do the same things, starting with the a sine H power here. They are somewhat similar as using the pre-reset, but when used with other variations, they make different effects. Like if you use it with like a Julian instead of linear, it makes quite different effects. The sine H power, a cos, a tan power, these really don't work in regards to using them with like elliptic and bipolar. And as mentioned, there are two really good tutorials here by Rick Sidwell. I will include those links. It has links to other flame packs and tutorials based on elliptic and bipolar. So on that, I believe we are done. If you have any questions, please feel free to ask. Until next time, bye.